For part A, there's a net force pointing this way and Fg pointing down. And since it asks for acceleration, there's a acceleration vector pointing towards the center of the circle, AC. For B, Fc is equal to Fnx. And that's the case because Fnx is the only force that's pointing towards the center. Fnx will be expanded to cosine theta, and that's because here this would be Fg, this would be Fn, right here would be Fny, and right here would be Fnx. This side would be the same angle. This side we'll call it a different theta, say theta of 1, so theta 1 plus theta is equal to 6 or 90. And because it's a triangle, it has to add up to 180. So one of the angles in the triangle is already a 90. And to make this a 180, there has to be a theta on the other side. So that theta will be adjacent to Fnx and opposite to Fny. We'll also expand Fc. And to find our R, this will be H, and this will be R. We're given a theta that's opposite to R. And because of that, since we're given the opposite and the adjacent, we'll do tan theta equal to R over H, and we'll isolate for R. And then we'll plug that back in. Tan theta will be expanded to sine theta over cosine theta. Cosine theta would cancel out. And that's our Fn equation. For C, we won't expand Fc, but also equal to Fnx, and Fn is also equal to Fn cosine theta. We don't know what Fn is, so we actually do know. It's right here. So we plug that in. And now equal to, and cosine theta over sine theta equal to cotangent. For D, we're gonna use the function of Fn equals to b squared over h sine theta. We don't know what Fn is, so we'll look at the y direction. We know that net force in the y direction is equal to 0 because it's not moving up or down. So this Fny is pointing up, and then Fg is pointing down. And then we'll move Fg to the other side, so they're equal to each other, and then we'll expand them. And then I'll isolate Fn because that's what we're trying to solve for. Then I'll plug that back in here. The sine theta cancels out. And that M also cancels out. And rearranging the function, look at b equals to square root gh. For E, at max speed, the block will have the tendency to move up the ramp. So because of that, the static friction would point down the ramp. Because it's pointing down the ramp, it'll be acting with the FNX, or the X component is, to figure out whether we should use sine data or cosine data for FX. For FS, so we playing down the ramp. We know this is data, and its components FSX, FSY, and then right here we use the same angle. So the angle will be opposite from FSX, so we use sine, and FSY, it'll be adjacent, so we use cosine, and we're gonna use FSY. We'll expand both sides. Then I'll factor out Fn. And we don't know what Fn is, so we look in the y direction. Again, it's not moving up or down, so net force in the y direction is 0. There's Fny pointing up, and then there's gravity, and then Fsy. That's also pointing with gravity. We'll move Fg over to the other side, and we'll leave Fsy to the left side because my plan is to isolate Fn, and I know that F static has Fn in its function. So by expanding it, and then isolating Fn, we can now plug it back into our original equation in here. So then the M cancels out, and then I move the R to the right side by multiplying both sides by R. And then square root both sides. And that's our equation for E. For F, now the speed is at a minimum. So when speed is at minimum, the block will have the tendency to move down the ramp. And because of that, the static friction will be pointing up the ramp. So Fc equals to Fnx. Now it's a minus. It's pointing the opposite direction from Fnx. We'll expand it further. And factor it. Then we look at the y direction to find a replacement for Fn. Now Fsy is now pointing in the same direction as Fny, so we'll be adding it. Then we'll expand it. We'll factor out the Fn. And multiply or divide both sides by sine theta plus mu cosine theta. So we'll plug it back into our original equation. M cancels out. And then we'll bring the r back up, or just up. And then we'll square root it, both sides. For g, judging by how it's a positive sign in the numerator and a negative sign in the denominator, we'll be using v max. So Fn is really just Fc, and we'll expand Fc. And then we have our equation up here. So let's plug that in. The v function at the top is squared, but the v at after that is, the v at the top is square rooted, but the v at the bottom, where it's equal to f net, is squared, so that would already be taken care of. The r cancels out. What I noticed about the function in part G is that there's a cotangent theta, and you can get that by doing cotangent theta equals to cosine over sine. So what I'm gonna do is multiply the top and bottom by 1 over sine theta. Now we can simplify it. So equal to cotangent theta W1 as well as V1, and then cotangent theta.